Welcome to lesson 11-3, combine volumes of prisms. So we're going to be combining the volume of the prisms. So with that, you're going to be figuring out 2, 3 different volumes of a shape, and then you're going to combine them. You're going to put them together by adding the volumes of each of the shapes you have made. So your I can statement that you need to write down is I can find the volume of a solid figure that is the combination of 2 or more rectangular prisms. So you're going to be finding the volume of each of the shapes and then combining them together by adding. So go ahead and push pause, write your I can statement down and push play when you're ready. And here is our solve and share. Once again, as you look at the shape, you can tell we're going to be combining the volume. It says Ariel is thinking of a three-dimensional figure that is made by combining 2 rectangular prisms. What is the volume of this three-dimensional figure? And we are going to circle the things that we're going to be using. And basically, we would be circling this whole shape because this is where our data is going to be coming from. As we box keywords, we're going to box combining, and we're going to box the volume. So we need to be thinking a little bit about what is our formula for volume. And volume equals length times width times height. And remember, another way to find volume is just to take the area times the height. So we've moved from those 2-dimensional shapes and now we're in 3-dimensional. So we're adding that height piece to this. So when we look at combining volumes, it's all about how you want to split the shape up. So I'm going to split the shape right here. So I'm going to be looking at this bottom shape. And I'm going to be looking at this top shape. So I'm going to have to find the volume of both of those boxes and then combine them together. I'm going to add them together. Now, another way you could have split the shape is to go straight down, and then you would be doing this back part and this part. But for mine, I'm going to start down here. So I'm going to look at the length. So for my bottom, I'm going to do the length as 4, the width as 6, and then I'm going to have to do the height. And so the height's going to be 2. So that's going to be for my bottom box. Now the volume of this top box that I have, and if you remember, I cut it right here, my length once again is going to be 4 times, and my height is going to be 5. Times the width, which is 2. 4 by 2 by 5. Okay, and then the bottom is 4 by 6 by 2. Okay, so now we just have to find the volume for all of those. So 4 times 5 is 20, and 20 times 2 equals 40 centimeters cubed. And then we have 4 times 6, which is 24, times 2, which is 48 centimeters cubed. And then we have to combine the volume, which is in our I can statement. So we're now going to take 48 centimeters cubed, and we're going to add 40 centimeters cubed, and we get 88 centimeters cubed for the volume of that 3-dimensional box. So when we look at Marisa's work, she split the shapes twice. Did. Yay. Okay, so she did 4 by 6 by 2 and 4 by 2 by 5, which is just how I split it. I split it along that same line that she did, and she got 88 cubic centimeters. And then let's look at Taylor's work. And they just kind of split each of the shapes so you could kind of see it that way, but they got 88 cubic centimeters as well. So Laura, when you come in, I forgot want you to write your keyword, and your keyword is going to be brown. And you need to summarize your thinking. And so you need to decide, how did you split the boxes? So I want you to talk about if you split your boxes the same way I did, or if you split them the other way and figured out the different volumes that had different dimensions. And then bring it to school tomorrow and we will be ready to share.